Welcome viewers. In this video we'll see the details about saddle pole induction motor coming under single phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic single phase induction motor in that shaded pole induction motor. We know that single phase induction motor is not a self-starting motor. How to make the self-starting? There is a first one is we have to do with the two windings. The single phase single winding is converted into two windings. Then the current flowing through these two windings should have a phase difference. Then only the rotating magnetic field will be created. If it is single winding, then the single current is flowing means the flux will be produced, but average of the flux is zero due to alternating nature, positive cycle and negative cycle, positive flux and negative flux. The net flux is zero in case of single phase with single current. With the two phase with the two currents, with the phase difference is there mean because of phase difference the rotating magnetic field will be produced. So we have to satisfy two conditions. There should be two windings and current flowing through these two windings should have phase difference. Now we'll see the shaded pole machine. So this is the diagram available. We have the stator and rotor. The rotor is available. The rotor is a scroll gauge rotor and the stator is there. Stator is a salient pole. Salient pole means projected. In that salient pole there are two parts. What we need is two windings. So there are two parts available. One is main winding. This is called a main winding. So this portion is also main winding. The B refers main winding. In that main winding, one small part is there, shaded coil. That is nothing but a copper ring. One copper ring is placed. That is A. Portion A is the copper ring, shaded coil. Similarly here, this side opposite, diagonally oppositely placed. The A portion refers the copper ring. So in the main winding, the stator is a salient pole stator. Salient poles are available. It contains main winding as well as shaded coil. Shaded coil is nothing but copper ring. Normally it is a single turn coil. Only one turn is available. When the alternating current is flowing through, the supply is given to the stator. When the alternating current is flowing through the field winding, what happens? Alternating flux is created. When the current is flowing through the stator winding, the alternating flux is produced. In that, the part of flux will link with the copper coil. Already one copper coil is available. So some portion of the flux link with the shaded coil. So it behave like a short circuited secondary winding of the transformer. So this will be primary winding. This shaded portion may be secondary winding is short circuited. So due to that what happened? The voltage is induced in the shaded coil that circulate the current in it. Right? So alternating current is given to the main winding. Due to alternating nature, alternating flux is produced. Part of the flux linked with the shaded coil. Due to that, a voltage is induced in the shaded coil. Then that will circulate the current. The induced current produced a flux called a induced flux. That will oppose the main flux. Right? So due to the current circulated through the coil, here one induced EMF is produced. That will oppose the main flux. So there will be the shaded coil causes flux portion A that lags behind the flux in the unshaded portion B. Right? So I will explain again. So the alternating current is flowing through the main winding. Due to alternating nature, alternating flux is produced in the main winding. The part of the flux linked with the coil. Due to that, it will act as a short circuited secondary winding of the transformer. So due to the flux linked with the coil and voltage is induced in the shaded portion. That voltage will circulate the current. Due to the current, the flux is produced in the shaded coil. That flux will oppose the main flux in the portion B. So there is a opposition between the main flux and shaded coil flux. So due to that there is a displacement between the two fluxes. What we need is, we have a displacement is needed. Now there is a displacement available between these two fluxes. So that net flux will be produced. Rotating magnetic field will be produced. Due to that, the torque is developed and then rotor start rotating, right? So the direction of the flux is from unshaded to shaded portion, right? So by using this shaded coil, that is the copper ring, we are making the single phase induction motor as a self-starting motor, right? So what we discussed, some description is there. We'll see the description one by one. So it consists of stator and squirrel cage rotor. The stator is made up of salient pole. Salient pole means projected. In that projection, there are two parts available. Each pole is slotted with one slotted on side, and copper ring is fitted on a smaller part A as shown in the diagram. So we have A and B. B is the main winding, A is the copper coil. This part is called a shaded pole. This ring is usually a single turn coil known as shaded coil, right? When the current is flowing, what will happen? When alternating current flowing through field winding, an alternating flux is produced. A part of flux linked with the shaded coil, which behave like a short circuited secondary winding of a transformer. Alternating current is flowing, alternating flux is created, the part of the flux linked with the shaded coil, so it will act as a short circuited secondary winding of the transformer. Now we'll see what happen in the next. So now the voltage is induced in the shaded coil and circulate the current in it. The induced current produces a flux called induced flux, which opposes the main flux, right? So based on the short circuited secondary transformer, voltage is induced that will circulate the current. That current will produce the flux called a induced flux. That flux will oppose the main flux. The shading coil causes flux in the shaded portion A to lag behind the flux in the unshaded portion B. So now there is a lagging occurs between the shaded portion and unshaded portion. That is the second condition to make the single phase induction motor self-starting, right? So already we have two windings, main winding and shaded coil. Now based on the current circulation and flux produced, there is a lagging occurs between portion A and portion B. Therefore, the displacement between the two fluxes set up a rotating magnetic field. Because of the lagging, the rotating magnetic field is produced. So a torque is developed on the rotor, hence the rotor starts rotating. The direction of flux is from unshaded to shaded portion. Right. Now we'll see the speed torque characteristics. So the x-axis speed is there, y-axis we have full load, torque is available. So initially when the speed increases, the torque increases gradually, it reaches the maximum value, thereby decreases and reaches the steady state value. This is called a starting torque. You see the starting torque is less than 100%. So this type of motor having less starting torque, used for only small applications. So it's a less starting torque. Now we'll see the further applications. Now see the advantages. Due to absence of centrifugal switch, normally we have centrifugal switch, that is we have main winding and starting winding. After the motor start rotate, based on the centrifugal switch, it will disconnect the starting winding. So that is not available in this motor. The construction is simple and robust, but this type of motor having lot of limitations, right? Centrifugal switch is not there, so construction is simple, but some limitations are there. So already we discussed, starting torque is lesser, power factor is very low. Due to I square R, copper loss in the shaded ring, the efficiency is very low. We know that already shaded portion is there, so the losses will occur, so the efficiency is very low. Reversal of speed is difficult. For speed reversal, the additional set of shaded ring is required. This method is complicated and expensive. Normally in other method, either main winding or starting winding is reversed so that we can reverse the speed. Here it is not there. It is the shaded portion is permanently fixed inside the rotor, inside the stator. So if the speed reversal means we need to go with a separate setup, separate arrangement, that is complicated. The size and rating of this motor is very small. Already we discussed a small type of motor. Low starting torque, low power factor and efficiency. These are all the some advantages, but we can use for small application. This type of motor can be used for small applications. Now we'll see what are the applications are available. Small fan toy motors. So in the toys we need only small type of motor. Advertising displays, film projectors, record players, gramophones, hair dryers, photocopying machine, etc. These are all the applications. So in this video we discuss shaded pole induction motor, single phase induction motor. The shaded pole is the additional winding that makes single winding into two windings. So the one requirement is we need two windings. So we have main winding portion B and shaded coil portion A. So due to the current flow and flux setup, there is a lagging occurs between these two windings. Based on that, rotating magnetic field is produced. Then we discuss torque speed characteristics, advantages, disadvantages, followed by applications. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.